In some ways, the physical layer of our network stack model is the most complex of all. Its main focus is on moving ones and zeros from one end of a link to the next. But very complicated mathematics, physics, and electrical engineering principles are at play to transmit huge volumes of data across tiny wires at incredible speeds. Luckily for us, most of that falls within a different realm. What you, an aspiring IT support specialist, needs to know about the physical layer is much more approachable. By the end of this lesson, you should have a solid foundation in aspects of the physical layer that will allow you to properly troubleshoot networking issues and set up new networks. Let's dive in. The physical layer consists of devices and means of transmitting bits across computer networks. A bit is the smallest representation of data that a computer can understand. It's a 1 or a 0. These ones and zeros sent across networks at the lowest level are what make up the frames and packets of data that we'll learn about when we cover the other layers. The takeaway is that it doesn't matter whether you're streaming your favorite song, emailing your boss, or using an ATM. What you're really doing is sending ones and zeros across the physical layer of the many different networks between you and the server you're interacting with. A standard copper network cable, once connected to devices on both ends, will carry a constant electrical charge. Ones and zeros are sent across those network cables through a process called modulation. Modulation is a way of varying the voltage of this charge moving across the cable. When used for computer networks, this kind of modulation is more specifically known as line coding. It allows devices on either end of a link to understand that an electrical charge in a certain state is a 0, in another state is a 1. Through this seemingly simple technique, modern networks are capable of moving 10 billion ones and zeros across a single network cable every second.